In this question, it says, if a laser has a wavelength, of 545 nanometers, and a pulse contains the energy of 1.85 kilojoules, how many photons of light are in this pulse? So initially, we read this and think, none of these values go together. But we need to remember that we can calculate the energy of one photon. So the energy of a photon, so EPH, is equal to h nu, where h is Planck's constant, so we can get that from the equation sheet of 6.626 times 10 to the negative 34th joule seconds. And then the frequency, we don't know that, but we know the wavelength. We also could think that, okay, so lambda times nu gives you the speed of light. So we could rearrange this equation to give me that c over lambda equals nu. So now I can plug in hc over lambda, where c is the speed of light, and that's 2.998 times 10 to the 8th meters per second. And that gives me the energy of a photon. So EPH is actually the energy of one photon. So this asks how many photons, but if you know the number of energy, you know the energy in one photon, you can just divide that and figure out how many photons. So the other thing we need to remember is this is in nanometers, and we need to get rid of that. So in 1 meter, there are 1 times 10 to the 9th nanometers. Or you could remember that 1 nanometer is 1 times 10 to the negative 9th meters. So I'm going to start plugging stuff in. 6.626 times 10 to the negative 34th joule seconds. 2.998 times 10 to the 8th meters per second, divided by 545 nanometers, and there 1 times 10 to the 9th nanometers in 1 meter. And so when I plug this into my calculator, I find out that there are 3.64 times 10 to the negative 19th joules and 1 photon. So now I can take my total energy of 1.85 kilojoules. I'm going to slide this up a little bit. Oops, sorry. So 1.85 kilojoules. We want to know how many photons. We're going to divide that by 3.64 times 10 to the negative 19 joules and 1 photon. And we need to convert kilojoules to joules. So in 1 kilojoule, there are 1,000 joules. So from here, you can plug that into your calculator, and you should get 5.08 times 10 to the 21st photons. And so this just uses basically 2 equations, the energy of a photon and the speed of light conversion, and allows you to determine how many photons are in a single laser pulse.